So here's CPM Calculus Chapter 2, number 36. So we're asked to write a thorough description of this function y equals to x squared plus 2x minus 15 over x minus 2, include a slope statement, a complete set of approach statements, and describe its end behavior. Okay. So before we get into this, let's kind of look, and we see, okay, here's our axis, x and y axis. Oops. Okay. So we see that there is going to be a vertical asymptote where the denominator is equal to 0, which is going to be at x is 2. So here, 1, 2, here at 2, we know that there's going to be a vertical asymptote here. Okay, so we know we do not cross that. Okay. Also, if we know where this crosses the x-axis, we could see where the zeros are, the solutions. So one way to do that is to plug this in your calculator and trace it, or look at where the zeros in the numerator are, and so solving this equal to 0. Or you can just factor the numerator. Okay, you can do that with the diamond method. You want to multiply to get negative 15, and multiply to get negative 15, add to get 2. Okay, so then that's going to be 5 and negative 3. So you can see that this is equal to x minus 3 times x plus 5 over x minus 2. So I just factored the numerator. Okay, this shows us that there's going to be a 0 at x equals to 3. So here, I'm using a different color. So here we're going to cross the x-axis here at 3. Okay, let me get some more points. 1, 2, 3, 4, 5. Just grow. And we're going to cross the x-axis also at negative 5. 1, 2, 3, 4, 5. Okay. And if you graph it with your graphing calculator, you're going to see that the graph kind of looks like this. So it goes up there. Here it's going down. Something like this. Okay? With the vertical asymptote at x is equal to 2. So now let's get into it. A slope statement. We didn't really cover what a slope statement is. So I'm going to skip this for now. But I would like to see, so skip this for now. What are the approach statements? Approach statements. So we know that x, so if we look along our x-axis, we can go all the way to the left. So as x goes to negative infinity, what happens to our output? Y goes to what? It goes to approaches negative infinity. Okay, so as we go to the left, 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 we're going down, 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 down. Okay, now we could also approach what? We could approach 2. So we're going up here, down here. So from the left, as x approaches 2, how do we say from the left? Well, we put a minus sign to the right of the number. So as x approaches 2 from the left, y approaches, so as we're going to 2 from the left, y approaches positive infinity. There, let me correct that. Okay, as x approaches 2 from the right, so we're on the right side of 2, we're approaching it, we're going down to y approaches negative infinity. And finally, as x approaches all the way to the right, infinity, y is approaching infinity as well. It's getting higher and higher and higher. Okay, so some things to notice. This right here is talking about its end behavior as x approaches negative infinity and positive infinity. And also we can see that the function is increasing from left to right, right? It's increasing, so it's going down, so it's going up, 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 up. And then it jumps down to negative infinity and keeps going up and up and up. So this function is increasing. It's never decreasing, right? So it's strictly increasing. What else can we say about it? We'll talk about other things later, but we could talk about concavity and things like that. But this ends chapter 2, number 36, the approach statements, talking about our function. Put a little sketch of it here. We have an asymptote at x equals to 2, and here's our function. So this is chapter 2, number 36 of CPM Calculus.